Yep, let's start now. So I had requested a couple of you guys or some of you guys to sort of start looking at what is IP address and all these things. Did anyone get a chance to look at it?
Sir, I got to know what is an IP address.
Okay, that's good.
Sir,
Yep.
an IP address is a set of numbers
Mhm.
which is separated by dots or
Yeah.
the periods, and it is used to label or define the different computers connected to the network.
Yep. Okay. That's a good answer. Very good. That's right. So what that was Ritesh, wasn't it?
Yes, sir, it was.
Yeah. So basically IP address, the reason why I'm just context switching from what we discussed last time, last week we discussed about OSI layer and what are some of the devices which are used in OSI layer. One of the devices which we discussed was a network switch, and another device which we discussed was about a hub. Do you sort of understand what is now the difference between a hub and a switch? And why do we use a hub or a switch over a hub? Or where do we use a hub? Where do we use a switch? Are we clear?
Yes, sir.
Okay, so can someone tell me what is a switch, a network switch, and what is a hub? And what are these devices used for? Where are these devices used for?
Sir, a switch, it connects many devices together in a single computer network.
Mm-hmm.
What do we say? Hub switch is used in data link layer, and hub, it is hub also connects multiple PCs to a single network.
Mm-hmm.
Hub is used in physical layer.
Correct. That's very correct. That's partially correct, or maybe you did not explain the full scenario, but yeah, but that's good. What you have done is very good. What I'm going to do is I'm going to stop the share on this and then share a whiteboard. So we spoke about a hub. A hub has got multiple ports. Hub is a device which is used to connect multiple computers, multiple devices. So as I explained in the last session, if you want to send a data from a server A or a machine A to machine B, assuming source is A and destination is B, in a hub, if you connect it, what happens is the data goes from source A all the way to hub. It reaches the hub, but it doesn't know where B is because there could be other devices connected to this. Yeah. There could be other devices connected like this. It could be a C, there could be a D. It doesn't know on which port of the switch this gentleman B is connected or this person B is connected. So what does it do? It sends out a message to everyone asking for, hey, who is B? Who is B? Okay. And this message is called a broadcast message. Okay. So someone might respond, say that, hey, B, I am B. Let me accept the packet. But in the event of a switch, okay, let me erase this. How do I erase this? Clear all drawings. Now, in the same scenario, in a similar scenario, where I have got a computer A, I've got a computer B. I've got other computers as well. I'm not drawing everything, but I am connecting these two devices through a device called switch. What is the difference here? When the packet goes from A to B, so the data packet, as I mentioned in the OSI layer, we have got data. The data has got a source address. We've got a source MAC address. It's got protocols, etc., 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 and destination as well. All this information goes through the OSI layer, gets added into the data. The packet reaches to the switch. You know what switch does? When B connects to the switch maintains a record of what is the MAC address of each of the device it is connecting to the switch. So switch knows where B is. So when you send a message from A to B, it doesn't have to send that message, hey, where is A, where is B kind of messages. So there is no broadcast messages happening like it would happen in a hub, okay? And this will help easy packet transfer from one device to another, okay? What is the benefit of that?
So it reduces traffic and it has more privacy.
Yeah, it reduces the noise. That's what is called as the noise, okay? Or conflict. It reduces the conflicts, or it in an optical terms, you might have heard the name in your classes called interference and all of those kind of things. Similar stuff happens in digital world as well, right? You know, in the packet transfer as well, the packet could get destroyed. To avoid that, they developed a new device called a switch, and the switch can read each data packet, and it also maintains a record of what is the MAC address of the devices connected to that device. In the case of hub does not do that such things. Hub does not have any intelligence. We did spoke about intelligent devices. In this case, a hub is a dumb device, and a switch is an intelligent device, okay? Because switch has got the smartness to understand what is the MAC address of the source and the destination, okay? So what we also discussed, these devices as used in different use cases. In some cases we use hub, in some cases we use switch. Hubs are generally not used in enterprise networks, and because of the reason that it causes quite a lot of data losses. But switches are mainly used because it helps in quick transfer of data packet from one device to another, okay? That kind of ends my session on the data link layer. Into is the network layer. To get into the network layer, you need to understand what is called as an IP address. In the data link layer, it is all based on the MAC address, as I said. In the network layer, it is more about IP addresses. Now, before I get into the network layer, I need to talk to you about IP addresses. And IP addresses, to understand the IP addresses, you have to take you to some of the basic stuff. So I'm just doing a bit of switching, so to speak, from the OSI layer and TCP layer and all these things to a bit of basics back, okay? Now, as Ritesh was saying, IP addresses are used, are a set of numbers separated by a dot. But why is an IP address used? Can anyone tell?
Used to send and receive information.
Yeah, but send and receive information. Why IP address? Why couldn't they use something else? What is the purpose of an IP address?
Sir, an IP address helps in communication by giving an identity to the computer which is connected.
Exactly. So it provides an identity to every single element which is connected to the network. Okay, so it gives a unique name. So everyone in this world has a unique name, yeah? So which is through which you connect or through which you interact and stuff like that. I speak to you by calling your name. You speak to me likewise. So all of this happens because each of us has got an identity. Likewise, in the world of computers, to get the identity, to get a unique identity, there was a system developed called as IP addressing. And IP addressing IP is nothing but Internet Protocol, right? Internet Protocol. So that's what is the expansion of IP address. So if all of you are using a laptop or a computer which has got a Windows operating system, not a Mac or Linux or something, this is the command you find to do this, to find the IP address. All right. Do you see that IPv4 address?
Yes, sir.
Okay. So that's my IP address. That's the IP address I'm connected to. Now, if you want to see, to see it on Linux, if or probably Mac as well, if you type this command, that's the command you should use. But this doesn't work on this because obviously it is a Windows computer. Okay, so just in case if one of you have a different operating system you're working on, it could be this command that you should be using on a Unix based operating system. Okay, now so if you want to find the address of google.com, let's see if it comes up. Do you see that? Okay, now you might have seen, or you might be curious to know, why am I getting okay, all right, let's do this, right? And let's look up facebook.com, and let's look up what gmail.com. Okay, when I did ipconfig on my computer, that's enough. It gave IPv4 address as 192.168, but when I did nslookup facebook.com, I got this, right? And this, all right? What it means is that this is the IP address. So I don't know if you noticed this. There is something called as v4, okay? And with what it means is that it is IP version 4, right? There is another reason why it is 4. I'll tell you that in a bit. And this one is IP v6. Okay. So just to go back to a history. So as I said, IP address is nothing but it gives a unique number. So what it is basically it is 2, 3, 4. I'm talking about IPv4. Okay, I'll get to IPv6 in a bit. IPv4 is nothing but a collection of four octets. When you say octets, do you know what is an octet? Okay. You know that anything around IT computers is what based? It's binary based. Okay, what is binary?
So the 0-1-0-1 combination.
Okay, so any number system, so the number system that we follow universally or globally is what? What is the number system that we follow? You don't know? You should know. Probably you don't know the name.
The Hindu-Arabic numerals.
No. Okay, yeah. But what is it called?
Roman numerals?
No. Have you heard of this decimal?
Yes, sir.
Yeah. Why is it called decimal?
So because it has a pointed number, which...
No. It's because it's got a collection of 10 numbers. So any numerical number that you arrive at is a combination of letters which are between numbers which are between 0 and 9. There are 10 of them, right? Correct? You don't agree with me?
So can you repeat again? Like
Okay. A decimal number is nothing but number derived from a combination of numbers from 0 to 9. The number of numbers from 0 to 9 is what? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 is not a, sorry. And 0 to 9, because 10 is a combination of 1 and 0. Right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 of these, yeah?
yes, sir.
Any number which is created, say for example 121, is a combination of 1 to 1, right? Likewise, so if you derive any numbers out of this, which is in decimal system, is based out of numbers ranging from 0 through to 9, correct? In decimal system. In binary system, we only use 0 and 1. We don't use anything more than that. So what will happen? So if you have to display the number 10, or write the number 10, you have to go 0, 1. What is 2?
So 1 1.
No, 1 0, yeah. What is 3? 1 1. Correct?
Yes, sir.
Yeah. So that's how that's how it progresses. In the case of 10, decimal system, 0, 1, 2, 3 to 9, and 10 comes as 1 0, because it is repeating again. And 11, 12, all the way to 20, and again repeats. Correct? That's how the number system is created. In the case of binary, you got only option between 0 and, in that world, there is no 3, 4, 5, 6, 7, 9 represented by a different digit. It is all represented by 0 and 1, because they don't think beyond that. Make sense?
Yes, sir.
Okay. All right. Now, there is another system. Have you heard of any other system other than now you heard decimal, now you know binary, you know decimal? There is another system. Have you heard of something called as hexadecimal system? Have you heard of this? Excuse my
No,
handwriting,
sir.
it's a bit poor. Hexadecimal consists of, so decimal consists of base 10, as in there are 10 numbers. Binary consists of base 2, there are only 2 numbers. In hexadecimal system, there is 16 of them. Okay. So in a hexadecimal system, you go 0 through to 9, then comes A, B, C, D, E, F. 9, 10, 11, 12, 13, 14, 15. So altogether 16 of them. So in that world of hexadecimal system, there are 16 unique characters representing the numbers. So what will happen in that case? So you kind of extrapolate the way in which you are representing numbers in different systems based on the number of digits it has as its base. Okay. Is it confusing?
No, sir.
I think it is. It should be. It's okay to be confusing. Okay, I'll
So can
make it
you
more.
explain this hexadecimal system again?
Yeah. So, okay, so please don't confuse yourself. Just take it as, there are different worlds. In different world, people use different ways of representing the numbers. Okay, in some world, which is common to all of us, which everyone is aware of, is the decimal system. In the decimal system, you have 10 distinct numbers to represent the numerals. After the 10th after the position 9 in the case of decimal system, it actually starts circling in because you start using a combination. So the distinct numbers are 10 of them. That is called as decimal system. All right. In a binary world, its decimal is base 10. In a binary world, it is base how much?
So base 2.
Base 2. In a hexa world, hexadecimal world, it is base
16.
16. What does it mean? In the case of base 10, you have 10 distinct ways of representing numerals. In base 2, you got only 2 distinct way of representing numerals. In base 16, they have 16 different ways of expressing numerals. So rather than going in, so think in decimal world. In the decimal world, you start from 0 through to 9. The 10th number or the 10th value is represented by a combination of 1 and 0 because you don't have any other number to represent. Okay. In the case of hexadecimal system, you have 16 different ways of representing the first 16, and then comes the reuse of the existing numbers. Okay. So you start from 0 through to 9, then A, B, C, D. So assume in the decimal system, this would have been a 10, B would have been 11, C would have been a 12. The same 12 in decimal system is represented by the letter C in hexadecimal system. A 13 is represented by the letter D. A 14 is represented by letter E. A 15 is represented by the letter F. What will 16 be?
G.
No. So remember, so 0, 1, 2, 3, and 9. After 9 came what? They started using 1 and 0. So it will be 1 and 0. Sorry, not here. Here. Make sense?
So sir, we continue the, like for 16 we do
So then you go all the way. You go all the way.
for the hexadecimal system in 16 we use the decimal system, the 10th one.
Yes, exactly.
Okay.
Okay. So
Yes.
these are different numbering systems which we use in the world, right? Now, in this case of IP addressing, I'm not going to talk about hexadecimal just yet. It will come to IPv6 when it comes to hexadecimal. I am not going to hexadecimal just yet. I'm going to go into the binary because that's more simpler and it kind of evolved, and I'll tell you where it reached now. Yeah, give me a minute. All right. So we were talking about IP addresses. Now, look, I think there was a session taken by Leon. I'm not sure if the video is available on YouTube. I strongly urge you to go through that because he was talking in detail about decimal systems and what was the implication of decimal system and all these things. If you want, if you can't find the video, probably I will sort of run you through that next week if you want. Otherwise, I strongly recommend you watch that because that gives you a bit of idea as to how the decimal systems are being used. Because how the binary systems are being used. Because binary system is the fundamental for any computer related operations. That is because, it is 0 and 1. In other words, how they represent 0 is a no and a yes, or a false and a true. So if you look at a scenario wherein which, just to give you a bit of an idea, just to give you, if for example, you are you are adding two numbers, 1 plus 1, right? Or what do you call, what are the other, there are binary operations, right? All those binary operations, like we do in decimal system, there are similar operations on binary, which are called or operation, and operation. I don't know if you have this in your curriculum just now. If not, it will soon come, because that's more important in terms of understanding how the IT internals work. Okay. I don't really want to go deep into it because that's going to take quite a lot of time. So I'll switch back to my thing. Okay. IP addressing. So TCP IP version 4. In the TCP IP case, there are 4 octets. Before we go into what octet is, before we go further into the 4 octets, I will talk about what an octet is. An octet is a collection of 8 digits in binary system. Okay. So 2, 3, 4, 5, 6, 7. 1, 0, 1, 0. I'm just giving a sample number. Okay. Do you know how to find the binary equivalent of a into decimal system for if a number is given? Do you know how to arrive at this number? Any idea? What does this number denote? Do you know how to find that? Okay. A binary the decimal equivalent of this binary number is, okay, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 5, 2 to the power 6, 2 to the power 7. Do you know what is 2 to the power 7? How much it is?
2 into 2 into last.
Yeah. How much is that? That's 128. Okay.
Actually, Jay, this Leon's course is doing it again from next week, 7, 8, 9, and 14,
Okay.
15, 16.
That's good. That's good. So I strongly urge you to watch that session, because it is important you understand how this is all fitting together. So just as an equivalent of, I'm just giving you a bit of an idea. So 2 to the power 7 in case of 128. So how we arrive at the number, we sum it up, and then what is the equivalent of that will be the decimal representation of 10101010. In this case, it is 0 multiplied by 2010 is 0 plus 2 plus 0 plus 8 plus 0, 32, 0. So 128 plus 32 is what? 128 plus 32, 150, 160, 168, 170. So I think it is 170. I could be wrong. Anyway, so that's the decimal equivalent of this number. Okay.
Yes, sir.
Okay, so all right, don't worry too much about it, because you're going to learn this in the other session that Leon is taking, and in that he will, I'm guessing he will actually take you through how you convert a decimal number to binary and binary number to decimal and all these kind of things, right? It's very interesting because you have to start thinking in a different mindset. So in a world where there is only 0 and 1, how would someone represent the number 151? He will guide you as to how to arrive at that. Okay. All I'm saying is, in the IP addressing, in the TCP IP version 4, we have got 4 numbers in a decimal system separated by 0, in a binary system separated by a dot, sorry, so not separated by a 0, separated by a dot, in a binary system separated by a dot, but the length of that is an octet. Okay, an octet because it's got 8 digits. Okay, so it's a collection of 4 octets which collectively make an IP address. Okay, why an IP address is used? Because like why a telephone number is being used, every single person, computer or a network device connected to a network requires a unique name or a unique identity. Okay, and that identity is represented using something called as IP address. An IP address is nothing but a collection of 4 decimal numbers in binary format represented by 4 octets. What is an octet? An octet is nothing but a collection of 8 binary bits, a 0 or a 1. Okay?
Yes, sir.
Yeah?
Yeah.
Okay, any confusion? I am happy to explain this again. Anything? Can I move on?
Yes, sir.
Yes,
Okay,
sir.
all right. Okay, now a fully populated octet. What does it mean? A fully populated octet means an octet, as I said, it's got 8 digits. 1, 2, 3, 4, 5, 6, 7. Oh, I have one more. It's got 8 digits in binary. A fully populated octet is an octet which has got all the spaces filled with a 1. Okay, you know what is the decimal equivalent of that? The decimal equivalent of that is 255. Okay, how you arrive at a decimal equivalent of a 8-digit octet will be explained in Leon's class. I'm not going to go deep into it just today. All right, a decimal equivalent of a octet which has got all zeros in it is what? Logically, what will it be? So if that is 255, what is it? What is this going to be? Simple, guys, don't think too much.
0.
0. Okay, all right, so what it means is an octet can start from a 0. The decimal value of an octet can start from a 0. It can go, the maximum value it can go to is, the maximum value of an octet can go to what? Because it can
8.
start with a 0 is
8.
what? No, that's 8 digits. What is the decimal equivalent of a fully populated octet? You're seeing on the screen.
255.
Yes. So if there is an octet which is fully populated, which means it is full of ones, is 255. Okay. What does that mean? It means that a octet, the number, the decimal equivalent of an octet from nothing to the maximum is 0 to 255. It cannot go beyond that. Does it make sense?
Yes, sir.
Okay. So what did I say? An IPv4 address is a collection of 4 octets separated by a dot. Correct? An IPv4 is a
Yes.
collection of an octet separated by a dot. A
Yes.
dot, a dot, a The maximum value of this 4 octets together will be, I mean the decimal value will be 255.255.255.255. That's the maximum value of a maximum value of a TCP IP v4 address. What is the minimum value?
0.
What?
0.
0 dot
0.
Okay.
Yes, sir.
All right. Okay. Now let me clear this. I'm going slow because this is very important you understand this. It would have been nice if you had attended the other or seen that video before, but anyway, nevertheless, don't worry about it. So in an IPv4 system, why did they come up with this? They came up with this because they wanted to uniquely identify each and every elements which are connected onto the internet. If we don't do that, what happens is that when a data transfer happens from one system to another system, the source system will not be able to understand where should I go and how do I address that person. Likewise, you know, say for example, Anil or Anseli is somewhere in the United Arab Emirates, I guess, or somewhere in that space, and I'm here in Australia. You know, if she wants to send me a message via a postal email, she will have to know my address, right? And I should have a unique address. My unique address is my name, my house number, my street number, and my city name. Ansley likewise has a name, a house number where she resides, a street on which her house is, a suburb on where that particular or the locality, right? You know, that's called address. Now, how do you do that in the networking space? The networking space, we do it by giving this 4 octets numbers. And the reason why they define it as 4 octet is because back in the days, they did not think that the number of computers or the number of devices which are going to be connected they had a fair idea what it is going to be, and that number was about 16 to 160 million or something, right? You know, they didn't think at that point in time they would have more than that many devices connected. So they came up with this 4 octet number, and you know, each one of them which are connected to internet will be unique. What happens if it is duplicate? Think about a scenario where there are 2 different computers which have the same IP address. What will happen?
So the connection will get interrupted because
Correct. It won't reach the right location, right?
Yes, sir.
Yeah. So they started experiencing this as a problem. So what did they do? They logically started separating the IP address into something called as public IP address and something called as private IP address. Okay, I will explain to you what is public IP address and what is private IP address. Okay, now, okay, so this is public, this is private. There is quite a lot of detailed documents available on the internet. Because you guys are you know, studying in different grades or different you know, levels, I am just trying to make it as simple as possible or as common as possible so that every one of you can kind of have a view. If you guys want to go deep into each of those, there are quite a significant amount of articles available on the internet. There are significant amount of videos available on the internet where you can go deep into it. You can also go deep into the IP address calculation and all these things. The reason why I'm not going deep into it is because some of this, some of you it might be too hard for you to digest. It might be too hard for you to digest even binary versus decimal, so I don't want to go deep into that unless you want me. I can do it in the next class if you want me, right? But at a high level, every device connected to the internet will, or not internet, sorry, excuse my language, any device connected to a network should have a distinct IP address. Why? If it is not distinct, there are chances that the data communications goes faulty, because the source and the destination, if the destination is duplicate, the data wouldn't reach the right recipient. Okay. In order to sort of mitigate the risk of the IP address running out, because the number of elements increases. Say, for example, nowadays there are devices, there could be 5 devices within your house, and assuming that each of those 5 devices has got a unique IP address to what is available in my house. If I have got 5 devices, then it will be like, the equivalent to the population of the world, or, somewhere around that space, and you will sort of run out of the IP address. To kind of mitigate that risk, they divided the network into something called as public network and private network. What is a private network? A private network is a network which is a very private. It has no visibility of what is happening in this space. Okay. It has got probably one leg into it, but that leg only will have a public IP address. Okay. I'll give you an example. Google.com, Facebook.com, what else? Gmail, Yahoo, right? All of these guys are publicly available to us, right? Obviously, for those kind of services or those kind of elements which are connected on internet, which are required to be publicly available, will carry something called as a public IP address. Okay. Now, all those devices which belong to your internal house, and it is only required to be connecting between these 4 devices or 5 devices, belong to the private range. Okay, a private range of IP address. Now, you might obviously ask me a question. Okay, if I am a private IP address holder in my house, how am I able to to view Facebook.com, which is public, Yahoo.com, which is public, Gmail.com, which is public? Because when I send a packet to Google.com, in the last class, Jay told me that Google.com responds to the source IP address. And if Google.com cannot see the private IP address, how is this happening? How is this connection happening? That is a very natural doubt that anyone and everyone could have, because I said in your home, all the elements which are available within the house is private, and all of those Google, Facebook, Yahoo are all public. Can anyone tell me how is the connection happening? What is enabling that connection? What is enabling the connection from a public cloud, or sorry for using that, because I'm tempted to use that because of some other reason. Why does Google.com, which is a public domain, connect to us who are working on a private network inside our house, able to communicate each other? What is the mechanism? What enables that? Last two sessions, if some of you have attended, you should be able to tell me what enables that connection. So I'm sitting and browsing the internet. Remember that session where we discussed about internet browsing and all these things? Someone helps me to get the packet out and pack it in. What is that device?
Sir, a modem.
Yes. How does a modem enables you to download the packet from google.com? Obviously, modem should have an IP address.
Sir, a modem sends it envelopes the packet and then it securely sends it to the receiving modem, and then it connects through different modems which help in communication.
Who is talking?
Sir Ritesh.
Very good answer, Ritesh. Very good answer.
Thank you, sir.
Okay. A modem, when you get a modem in your house, you get a modem and you get connected to a service provider. Isn't that right?
Yes.
Yeah.
Yes,
So Ritesh, for example, can you tell me where you are? You are in Kuwait?
sir, I'm in Oman.
Oman. Okay. You might have a connection with one of the mobile service providers, or you might have a connection with one of your broadband service providers. Is that right?
Yes, sir, we have.
Yeah. Can you please tell me what is the name of that service provider?
Sir, it's actually Omantel.
Okay. Omantel. Omantel is the service provider. Now, what happens in the case of so when we subscribe to an internet connection through a service provider or through a mobile network, what happens is that you get a public IP address assigned to you by the service provider. Okay. So you have a private IP address internally to every device that is connected to internet through a Wi-Fi router, and the Wi-Fi router helps you get a private IP address, correct? And your modem and your service provider helps you get a public IP address. Only if your address was public will Google be able to send data packets to you. Otherwise, Google wouldn't know who you are, right?
Yes,
So
sir.
you need to have a public leg. When I say leg, not your physical leg, but you have to have a public access. And that public access or your public gateway is your internet service provider providing you with a public IP address. Okay.
Sir, so the internet service provider provides both a public server and a private server into the modem.
It is not a server. It is an IP address.
Yes.
So internet service provider provides you a data communication channel through your telephone cable or your optical fiber cable, which is connected to your home. And through that service, he also provides you a public IP address.
Okay, sir.
Your router, you might have a modem and a router combined, right?
Yes, sir.
That router has the ability to provide you with a private IP address.
Okay, sir.
All right, I'll show you how that works. So what I'm going to do today is I'm going to show you IP config, right? In this, I am taking this part, the gateway, okay? And there is an IP address attached to it. You know what is that IP address? That is the IP address of my Wi-Fi router. You can try this, but if you do something wrong, and if your parents are upset with you, don't blame me. But you can try this. Nothing wrong in trying it. Can you see this?
Yes, sir.
Yes, sir.
Okay. In this, I get a look at that. I get a DSL connection, which is nothing but a broadband connection through a cable, right? Through a cable, right? And I get a public WAN interface name. All right. Okay. Do you see that? This will be common across the board. In every modem, you will get this. And you would get a MAC address. We spoke about a MAC address. We also get something called as 203. And this is 203 for my country. It could be a different number for your country. So geographically, it is different pool of IP address used by different people. This IP address is my public IP address. Okay. Now I go to my wireless. The wireless device at my home has the ability to provide IP addresses, and that IP address is the private IP address. So in this case, I've got an IP address of 192.168.1.102. The device, which is my Wi-Fi router, provides you with that IP address. Okay. The internet service provider, in my case, is Vodafone. Vodafone provides me with the public IP address. Make sense? And that's the public IP address for me. Now you might think, I've got 192.168.1.102, which is my IP address. There could be other devices within my network. How are all these guys, when it reaches the modem, be able to communicate with google.com independently? Correct? Is that a doubt that you're getting?
Yes, sir.
Because if, for example, Ritesh has got a sibling at home, he or she also might be accessing google.com while you are accessing this network, right? The Zoom network or whatever. How is this possible? How is that you have a private IP address, your sibling has a private IP address, your parents has another private IP address on his or her device, but all of them are able to reach the public network, obviously through the modem, but the modem has got one IP address which is public. How does that happen? Can we take that as a homework for you to sort of go work it out? If you do not get it, that's fine, right? But I'm just trying to sort of instigate your thought process in that way to find out how would multiple devices in a private network are able to connect to a public network through one public IP address. Can we stop here and then wait for the next session for an answer? If any one of you are interested to sort of do a research on that, please do and come back. We will discuss on it next week. Is that okay?
Yes, sir.
Do you guys find this interesting to find all these things, or is it too boring? Let me know.
No, sir, it was interesting.
Yeah.
So it was interesting.
Okay. All right, good.